All right, everyone, let's restart the session. The second talk I have here with me, Upendra and Kshitij. They have two things in common. They are both master students at the University of Salzburg, and they are also both from Nepal, or have roots in Nepal. And they are going to present us this tool called VirtuGhan, a virtual computation globe. Looking forward to that.
Am I audible?
Yeah, it's on.
Can you hear me? No? Okay. Okay, I see. My voice is little low. I hope you listen to me, hear me properly. On the back? Okay, thank you. Hello, everyone. Today we are here to present VirtuGhan. It's a virtual computation cube that we developed during our study of masters in University of Salzburg. So it's basically about the satellite data, how you handle satellite data, how efficiently you manage and process the data sets. So speakers, myself, I'm Upendra Oli. I'm from Nepal, as you mentioned. I have a company in Nepal that works on geospatial technology development. And we are now currently more than 100 people who work in software development, mostly on the geospatial softwares in Nepal. Right now, I'm studying in University of Salzburg in Austria together with him.
Hi, I'm Kshitij. I'm from Nepal also. I study alongside with Upen. I also work at Hot. And nice to meet you.
Okay, then let's start with a little bit of history, background story, because this whole concept started when we were learning in the university, and we came to know about Google Earth Engine and trying to get along with it, and then we also get to know about the data cubes. And we are very fascinated about how Google Earth Engine does the computation while zooming in and zooming out. And every time you zoom in, it does the computation and gives the result, and then zoom out, it gives the result on the fly. That's what we were fascinated about, and then we wanted to learn more. And since the Google Earth Engine is not open source, and we were thinking like, can we do it in an open source manner? And then again, we went through the data cubes. If you don't know about data cubes, it's a stack of satellite images put together. Let's say different time of satellite images, if you put together, it forms a cube. That's basically called the data cube. And those data cubes generally are developed by different organizations, different research institutes. But what we came to know is these data cubes, they use massive storage. They use, as you know, that satellite data sets are getting bigger day by day. That means you can imagine only one satellite, that Sentinel-2, is generating 3 terabytes of data sets. That means it's getting huge and huge, and it's a big data that's headache of many people. So instead of placing it in proper place and then reusing the sources, people are trying to duplicate the data sets and store it by themselves and processing themselves. And another problem or challenge we see with the data cubes was they actually compute beforehand and compute on the whole image. That means they are pre-computing things and storing so that they can provide the data when user requests it. And that creates another challenge. Like, you can store the data, yes, but it's very, very costly, because some data cubes, they might cost around thousands to millions per year. That means we need a low-cost solution. That's where we thought that we could jump in. Okay, we can think of a small idea that can tackle these kind of challenges. And to just showcase what is VirtuGhan, just a simple example. It might be pretty simple example for you, for some of you, but let's go to the Pakistan, in Kharpur, where 1/3 of the whole country was under the flood. and several people lost their lives. These kind of disasters need pretty fast response. You need a pretty good solutions to find out where to focus. The humanitarian people or the government, they want to know where to focus, where are the people, where is the flood, most affected places, and then what you can actually do is generally people what there are different options that you can do. For example, you can either hire a drone guy who can fly the drone over there, or you can purchase the satellite image or ask the satellite image providers to provide the origin satellite images, or you can basically use the free data sets that are available in the market, like Sentinel data sets or the Landsat data sets. So what happens in there is, if you want to download, if you choose that option, if you want to download, you have to download the whole image. That means you are downloading more than 1 GB or 1.5 GB of the data sets. Imagine if you are in a low connectivity place where internet is very slow and even 1 GB could take you a day. Then in that kind of situations, you need a fast and efficient solution that can, let's say this one, the very small red one, that is your area of interest. Let's say that's a pretty big town, but it looks very small in a big image. But you have to download the whole scene. That means there is a challenge. And how VirtuGhan could help? Yes, we are trying to tackle that challenge so that only a small portion of the image can be downloaded, so that people can use on their computers, or even within VirtuGhan they can compute themselves and generate the result and download the result itself. And then, oh sorry. So it also works across different time levels and zoom levels. And we call it VirtuGhan or virtual data cube because it doesn't store the data sets. It computes on the fly and then gives you the result. And then if you want to download the data sets, only that part of data can be downloaded as well. Next. So what we are trying to do is basically trying to save cost and energy and trying to distribute the load that only one server might have. For example, we are saving the cost and energy by just using whatever you need, because computing the whole image and storing it in somewhere, it takes a lot of energy and cost for you. In terms of server cost and in terms of energy, in terms of AC consumption that the server can use. And also we are trying to shift that burden to the computers of the people. And then there is also a small, very simple but useful UI where people can also go there and just do their stuff. And looking at the features that we tried to develop, the features that we felt they are very useful to the people. And first one is a live view that I talked about, how Google Earth Engine computes over tile so that you can do the computation on the fly in an open source manner. And then where we can get the layers on demand, we can apply the formula and then also get the aggregated information of different images of different time, and then get this type of maps or layers where you can use as a base layer or whatever layer you want. And then if you go to the next module, we call it analyze, where you compute the data sets on the fly, get the data sets, compute it, and then visualize the result and even download the result. It means it's not computing over zoom levels, but it's computing in one zoom level, which zoom level you choose, and then getting you the results, whatever you want, using the formulas. For example, we call it NDVI or NDWI. It's a vegetation and water index, where you can see where are the vegetations and where are the water, using that indexes, using different colors. In this image, you can see different colors, like water is represented in green. This way you can interpret satellite images. And then third one would be to download. As I mentioned, you can download the small portion of the image and use on whatever you want to do on it. And the good thing about this is you can develop on top of it. You can develop other solutions because it's uh, published as a Python package. And I was just checking at the stats of download. I'm happy that it's being used or being downloaded as well, because the last month we had 78 downloads. That means proof for us that, oh, okay, some people are using it. And now we moved forward with how it works, more technical side that my friend is going to talk about.
Yeah. So you probably this uh, concept is implemented on top of cloud native geospatial file format. So basically, how whenever like you have a big geotiff and then you convert it into cloud native geospatial file format, so that you can only get a specific part of the file, right? And then so it's built on top of that. How stack APIs are built, you can use it. You can have a drone image, convert it into like use GDAL, convert it into cog, and then put it in somewhere and build on top of it as well. But for us, we also use stack. Local images are also supported. You can convert it into like and serve it as a tiles. It has a fast API endpoint which can handle your tile request, and then it computes the bounding box, uses the mercantile tiles, gets the tiles, and then what it does is it creates those on those tiles. It is stacks based on your request. So if you have okay, data range from 4 months and until 4 months, Sentinel-2 has okay 10, 15 scenes, then it will get that specific tile from different scenes, and then it will stack each other up. It works on a memory. That's why it cannot do a whole bunch of computation on city level for sure. It is not designed to do that. It is designed to see only what you are looking at the screen, so that like in Google Earth Engine, okay, you put a code, click on run, you see it, zoom out. And when you zoom out, it desamples and gets the bigger tile, go to the scene, gets the bigger tile, and then does the computes the box again. So this workflow is how each tile is processed. It can be computational heavy, so, does consumes resources, but also that's the whole point, because it is also saving you the like need of downloading the data set and putting it, and it is doing on the fly. And it's we try to build it as a little bit more efficient so that it can be deployed as a Python script in AWS or in your server. You can have a cron job, and imagine like, let's say you want to monitor 20 different glaciers in your area of interest, then you can simply have a Python script that takes you define a source, like define a stack that you want to look into. It could be from ESA, it could be from AWS, and then it will go through that every day, checks, runs your logic, does the computation, and based on that result, you can even attach it to AI model or attach it to some mathematical expression. Okay, if this happens, email me. If this happens, email me, and it will die. Basically, the whole purpose of this is to have a efficient tiny tracker that can be even plugged into your laptop, plugged into your server, or anywhere else. So yeah, for each scene, it applies the math computation. So also like how tiler works, gets the tile from the cog directly. So what it does is on top of it is it creates the stack of it. It applies the formula. So while fetching the tile, it will apply the formula that you have supplied. It could be band 1 minus band 2 plus band 1, weird formulas, whatever you come up with. And yeah, that's why it's a virtual data cube, because it's in the memory, and then hierarchy and history. It also does do little bit of cache. So if you wanna like keep looking at the map, zoom out, zoom in, so that it don't have to compute every often you zoom in and zoom out into the map, because on the lab view, people tend to do that when there is a map. I tend to do that. That's why it does cache. It has a Redis support. It uses local cache as well, and it gives you the response in the type. So application areas, it can be, I don't, you can also be more creative than me. It can be used in deforestation. The most thing I can see like glacier treatment mostly would be useful if you have tiny different areas and you want to track them basically, and you have a tracker on your pocket that you don't want to rely on big servers or like anything. And yeah, you can do environmental monitorings, agriculture monitoring, and different area specific. So what next? We have integrated concepts, some algorithms for Sentinel-2. We haven't. There is a work in progress for Landsat 8, Landsat 8, 8 and 9, and yeah, once, but it's still in like under review. Once it's a review, it will be available in the production and modis and other commercial sources, so that you can make like better insight from those data sets. Why those needed is like, for example, while developing, we figured that Sentinel-2 needed some algorithm in order to filter the scenes when it tries to grab the tile. Like, we need to figure out it does not fall out of the tile bounds. And then sometimes like Sentinel images will be repeating when the satellite goes through the same area twice. And yeah, that's why we wanted to implement some like cleaning algorithm for those sources. So there is also a work in progress to develop a QGIS plugin, because whole point is to you do computation on your laptop, not on our servers. You can use that on our servers as long as we have money, but we don't. Uh, and so yeah, there is a QGIS plugin. Once like work in progress, once this happen, it will process it on your laptop. So get the tile from the stack, like a server, and then all the computation will be done in your computer. But on the tiles, it won't do it on the scenes itself. So yeah, integrating AI, you can think of as like we were thinking of maybe for this snow covered changes, like a climate changes issue. If you want to track glaciers, then maybe can have some like because it everything works on 256 by 256 tiles. It is easy to like feed them into AI workflows where you can make a predictions on top of it and then do some trigger actions. And then, yeah, so that we can create those workflows, basically. That's the next that we are thinking. This is one of the case study we have done. This is Los Angeles fire that we were like watching. So for this, like it would be as easy as, okay, you go to the area, try to, this is a bond ratio that we it's a like formula that can do bond normalized ratio. I think it uses Near and Swear, yeah, sort of infrared. And then, yeah, so this is how like we were looking at the changes for the fire. And this is quick demo, like how it works is you use it to also export for your area of interest. Okay, if you click on it, what it will do, it will figure out which are the tiles that are needed on this area of interest that you're looking into. You can also use it to download Sentinel-2 images. When Landsat is coming, it would be Landsat images. You figure out which band you want to go. It will build the cube accordingly and then get you the data. It is quite yeah, it is quite fast. Also depends on internet speed for sure. And yeah, you can also visualize the result. You can see the trend. Also, you can also see it in a live view without doing the computation. You can just put a formula. You will see the result immediately. And when you zoom out, it will desample and see the result. But if you wanna download it, it will download it in original resolution. Similar how Google Earth Engine works. Um, that's pretty much. This is a Python implementation, because whole idea is to you build your small, like it could be like let's say similar implementation that you see in data cubes, but here is like we wanted to build something that we can deploy on our own, like have a script, keep it running, keep monitoring some things that I want to monitor. So you can just like install it and then build on top of it, so that you can send emails to your friends if something happens, or do your stuff. um, so yeah, thank you. You can get the project details here. I'm pretty sure a lot of you are developers. If you want to contribute or like provide some suggestions, then that's more than welcome. We'd be more than happy. You can contact us using those QR codes. Thank you.